Okay, hello everybody at home. Can somebody speak up just to make sure that you can hear me? Anybody at home, or you can type a message on the chat. Okay, so we're good. All right. So guys at home, if you want to ask a question, make sure that you do speak up because I can't be monitoring the chat all along the lecture. So just make sure you do speak up. I do have the speaker on loud, so whatever you say, I can now hear you. All right, so inshallah, we get started today. Now, the point behind today's lecture is to understand the differences between the different types of requirements. All right, it's very important so that we don't actually end up wasting our efforts when we actually get to do the development to realize what are the differences between the different types of requirements. Now, in the next lecture, or in the next chapter, should I say, because we might actually begin the next chapter this lecture, depending on how this lecture goes. We will see how we begin the actual project and differentiating something between the problem domain and the solution domain while we're still in the requirements phase. I know I said in the first lecture at the course outline that the entire requirements phase is called the problem domain, and it is, okay, but even within the requirements phase, we can still split it into two phases, one of which is still called the problem domain. Another one is called the solutions domain. And this is where the project still is in its infancy. All right. And the chapter after that, this is where we begin by explaining, I'm going to explain to you the actual process of requirements engineering. All right. So we know the process of software development in general. Okay. We begin with requirements, followed by design, implementation, testing, all that's in-house. And then as soon as it goes out, then we hit the maintenance phase. And as I said before in the last lecture, make sure you do get that maintenance contract because that's where all the money is. So this, I'm giving you kind of like an outline of how the lectures are going to go, right? There are four main processes in the requirements engineering phase of a project. And then a whole bunch of lectures afterwards is going to be talking about the different four processes, okay, all the way towards the end of the course. And towards the end of the course, we'll start talking a little bit about software requirements management. All right. So today, or in this chapter, I'm going to be explaining to you the different types of requirements that we have. All right. Just make sure I get this. Okay. All right. So what exactly is a definition of software requirement? All right. The general guess is it's a requirement. It's something that we require. It's something we require the software to do. All right. And funny is that we're actually explaining the problem. I mean, as intuitive as it sounds, the word software requirement, okay, it's so common that what we end up actually doing is explaining how the system will actually do its work. And this is not our job. Okay, we're still at the requirements phase. We're still trying to figure out what is it that we're going to be building. Okay, and again, imagine in civil engineering or architecture engineering, when you see that empty land and you see that picture of the building that will be erected later on, the creation of that picture is the requirements engineering phase. Okay, that is done before any labor is involved into the actual construction of the building that we're going to build up at the end. All right. Now, in software, it's the exact same thing. We are trying to figure out what is it that we need the system to do. All right. What is it that we need the system to do, and under which characteristics? Okay. Now, the word characteristics usually comes in the form of constraints. Okay. So there's a difference between doing something, but doing something with a certain performance. That's a different thing. Okay. So, our software is able to do a piece of functionality, great, but it needs to also be secure. So if it does that functionality without it being secure, for example, it reveals information about the user, that's not good. All right. Or it needs to be able to do a certain piece of functionality, but it needs to do it within a certain amount of time. Okay. That time is a constraint. So if it does it, but it exceeds that time, that's not good enough. Okay. And this is where we come into something called function requirements and non-function requirements. We're going to get to that in a moment. So it's a software capability that must be met or possessed by the system, all right, to satisfy a contract. Because this is usually what the functions is what the customer is paying for. This is what they're most excited about, rather than the constraints themselves. Okay, I mean, usually you coming back with the customer and saying under this constraint and under that constraint, and they be like, oh yes, yes, well, of course, right? Like, I want to be able to perform that transaction and so on. Yeah, yeah, but obviously while being secure and integrity, well, of course, yeah, we need to be able to do all of this, right? But this is not what they're most excited about. What they're most excited about is the capabilities. All right. Or other formally imposed documentation. All right. We have 5 major classes of information or things that we need to consider when we are considering the behavior of a system. All right. Obviously, the first of which is the inputs to the system. The inputs to the system could be in the form of human input or could be in the form of a device input. Okay. Or it could be in the form of a communications input. These are the 3 most common ones. So human input, that's normal. That's what we do with our phones. That's what we do with our laptops. This is what I'm doing right now with these PowerPoint slides. I'm giving it human input. All right. Sometimes you can get a hardware device input. Okay. For example, you have a sensor, you have a barcode reader. Okay. These are very specialized hardware that you do something with it to get the input from. Another thing, it could be a communication. For example, you know, you're on a website and you want to hit a particular server because you want to get a certain web page, but there's nothing per se physical that is happening more than it is. There's a software communication aspect, and there's protocols that you undergo, and they make sure that they do the handshake and so. But all of these are just computers talking to each other. But nonetheless, doesn't matter which type of input it is considered input. The other thing is the output that you actually exhibits from the actual software, okay, or system. So the output could be something audio, okay, it could be something visual, it could be some sort of a machination activity that actually happens. For example, the ATM machine and how it actually produces the cash. That's an actual machination. It's a machine doing something. All right, a robot moving, a light turning on. This is all certain types of machination, but nonetheless, it's still an output. So the output could be something like a computational value, or it could be, you know, a signal sent to a certain hardware device to do something. Okay, right now you should be taking digital logic, right? Yeah. Okay, and in that, hopefully, you'll see how you can do a little bit of programming in assembly where you actually can send signals to pieces of hardware. Sometimes it's just a little light bulb, and basically say turn on, turn off, turn with your software. And it's pretty cool. Yeah, you actually write software to get the light bulb to turn on and turn off, or maybe you sometimes turn on and off in intervals, like 1 second on, 1 second off, and so on. All right. Now the third aspect is the computation is actually happening inside the system, the functions that are actually occurring inside the system. Okay, this is where we as software engineers really earn our money, is where we get to program the software to do certain things, certain functionalities. Matter of fact, a lot of times the functions that we actually create is what we call functions. This is what we teach you. We teach you this is called a function. Some other types of communities call it a method, but or operation, but it's still called a function at the end of the day. Okay. And what the function does, it's the man in the middle. Okay, it gets input, does some functionality with that input to produce that output. Or in other words, you can think about that function as a mapping function. Okay, given this input, I'm going to give you that output. Okay, so if you give me a 3 and a 2, and this is an addition functionality, I'm going to give you a 5. So that addition, that function is a mapping function from the 3 to the 2 to the actual 5. It could be a square function. Okay, in this case, I just get one input. You give me a 3, I'll give you a 9. You give me a 2, I'll give you a 4. And it's a mapping function. And in this case, it's actually a one-to-one mapping function between the input and the output. All right. So you, Mr. Function, do whatever it is that you have to do, but somehow get that input that I'm giving you to translate to that specific output that this is what I had the vision for to begin with. All right. I know what the square of 3 is. I want you to do it, Mr. Software, right? The other last two are called attributes. Okay, the first attribute is attributes of the system. There are non-functional requirements like reliability, maintenance, availability, and the throughput. Okay, we're going to talk about these in a second, but these are the characteristics of the function. So I said a moment ago, it's not enough that you actually doing the function, but sometimes you have to do it within certain constraint. Okay, one of these constraints could example be security. Okay, another one, for example, scope, for example, availability, like you see over here. Okay, the fact that it actually is available is in itself a quality feature. All right, so one thing is about that software doing these amazing things that it's doing, but the fact that it's actually being available is a different thing. Now imagine you are actually using a piece of software or booking with an airline, all right, or using a banking system, right? But that banking system is amazing, it's great, but the only issue is that it's only available for half an hour a day, all right? Imagine another banking system, it's not as sophisticated, it's not as amazing, but it's available 24 hours 7, 24/7 a day. So 24/7 all the time. So obviously you'll be leaning more towards working with a system that is more available. Okay. Another thing, for example, you see over here is called maintainability. I'm going to get to your question. I'm not going to ignore you. But maintainability is something that deals with the life cycle of the software. Okay. So I could produce software and it's doing all this function and all this stuff. Great, right? Things are going to change. I'm going to need to update that software. But if that software is so rigid that it can't change, its life cycle is not going to be that long. It might actually last a year and a half, 2 years. But at some point, I'm going to have to put it off on the shelf. Example, imagine if I produced, say, a registration system that you were just dealing with a couple of weeks ago with the Net Classroom, okay? Part of it is we programmed the prerequisite, okay? For in order to register in this course, you have to have the prerequisite of 201, okay? Maybe a few years down the line, we decide, no, we don't want to have 201 being a prerequisite of this course. We want to have something else being a prerequisite of that course, right? But the system is so rigid and no, sorry, we can't do that anymore, right? So what we're going to end up with, either we are just going to get accustomed to the system and change our own curriculum, which is unlikely going to happen, or we're going to say, the heck with that system, we're just going to move on to another system. So maintainability, the ease of changing the system is in itself an attribute of the system. And you better take care of this as we're building the system. Don't come and look at it at the very, very end, okay? Another word here is called reliability. It's one thing that I get the correct answer once. It's a different thing that I get the correct answer every time, okay? This is called reliability, all right? Maybe sometimes you see that with Uber, all right, where you get into the car and you want to go someplace and you look at the route that it's recommending, all right? First time you get into, you go to the same place, work or school or whatever, right? And it's taking the proper route that it should. Next time, does the same thing. Next time, does the same thing. But the third time, you get into the car and for some reason it's taking you through a very, very weird route, okay? With a lot of U-turns here and a lot of U-turns, and you have no idea why it's doing that, okay? That's a reliability factor, okay? So you can't really feel like you can depend on it every single time. I know this is gonna work 90% of the time, 50% of the time, but it's not 100% of the time, okay? I know it's hard for us to imagine because in the software that we developed in SC100, all right, it's always the same input, you get the same output, it never changes, okay? But that's not always the case with other types of more sophisticated software where, you know, it works with certain conditions and you're expected to produce, say, the most proper answer, and sometimes it doesn't, all right? Yes, the question at the top.
One of the attributes wasn't there. Does the project fail?
Might actually fail, all right? So if the customer didn't pay attention to those attributes, okay? For example, one of those attributes is the confidentiality and integrity of the information that is going back and forth between the bank and you, all right? And for some reason, even us as requirements engineers, we didn't actually do our job in recognizing this attribute, okay? It's not gonna be long before the system is exploited and then your bank account is drained. And then obviously it's gonna be all over the news all right, and then that system is going to stop. So you're going to produce the software, but it's not going to last that long. Okay, it might even end up reaching a situation where you're not actually even having successful completion of the project, depending on the nature of the project. But certain constraints and certain attributes need to be there, whether we recognize them or not. Okay, same thing with the risks. The risks are there. It's just only a matter of the cleverness of us recognizing that it is there versus us being oblivious to it being there. Okay, so that risk is, in that case, is a hacker sitting outside who's trying to get in and trying to steal your banking information. If we're oblivious to that, we're too naive to that, it's gonna happen. Yes.
Over, do you know in the testing stage where you test the software rigorously?
If I didn't account for it from the very beginning, probably not. Okay, and this is our job as a requirements engineer. Okay, even if I consider something that's a little less malicious. Okay, so I have a hospital system. Okay, you know, it should be the case that I'm creating this software to be used by doctors and nurses. All right, if I create the software with just functions that are only accessible by doctors because I was completely oblivious about nurses, well, then the nurses get to use the software, they can't use it. All right, same thing as I'm saying right now. You say, well, a lot of doctors are nurses. It's pretty obvious. Okay, what is another thing that's maybe not so obvious? What about the patient themselves? The patient actually using software in the system, okay, which we actually do. Believe it or not, all of us have like an app that you can use to register an appointment, to book an appointment with our doctor. We're actually interacting with the software system of the hospital. Maybe that wasn't possible 10 years ago, but now it's very, very possible. All right. The last category of information is attributes about the system that is actually working. For example, the hardware specifications that we have, the software specifications that we have, the operating systems, and so on. That really tends to play into the performance issues. Okay, how much throughput can that system have? Okay, so it's one thing that I handle a transaction. You try to buy a book from my store, but it's a different thing that how many transactions can I handle as customers, all right, in a minute. Okay, if I get 10 customers, yeah, I can handle, but if I get 100, maybe that's too much. I end up dropping a few of them. All right, so I have to understand the system that I have. All right, if you're working with Windows 10 that we have right now, is it 12? I don't know what it is. Okay, it's different than if you're dealing with Windows 98, one we created before you were born. Okay, if you're dealing with a network that is, you know, oh, fiber this and fiber that, is much different than if you're dealing. And I have to be aware of this, okay? Because going back one step before, one of the things that I said was I talked about performance. Okay, so if I'm not really aware of my network, all right, and how it's going to perform, and I'm going to make my design based on a certain network performance, I realize at the end that it's a lot slower than I expected. That network, although it's not really my fault per se, okay, but that network that I'm using is exactly, okay. It doesn't have to be network, okay. It could be something like you know, if this system that I'm developing, is it, you know, an iOS app or say an Android app, okay, where the inputs come in slightly different flavors. All right, so all Android apps and all phones that are developed with Android as its operating system have certain physical attributes. iOS has something completely different. All right. All right, so this is a picture. All right, so you get the inputs. Right from here, let me just do this for the guys at home. There's a pointer. So you got the inputs over here, right? This is the outputs. The functions is what's being crunched in the middle, but there's a couple of attributes that we need to watch out for. The first of which is my system attributes. What are the software that I'm using? What are the hardware that I'm using? And obviously the attributes that I want for my system to perform under, whether it's performance, reliability, throughput, and so on. All right. Now, requirements engineering is supposed to tell us what, not the how. All right. We should exclude things from our requirements that talk about, for example, project management information. Okay, like Hussein is going to be doing this. That's not, there's no place in this in requirements engineering. Okay, All right, Ibrahim is gonna, are we gonna do this in 3 months? It's got nothing to do with requirements engineering. Okay, 3 months got nothing to do with what the software is gonna do at the end. Okay, uh, other information about this, for example, this class is gonna cost us 100,000 reals. Again, no place in the requirements phase. Okay, all of this is management stuff. Not our problem. Okay, should have no place in it. Another thing that doesn't have any place in it is design information. Okay, we're gonna use this protocol. We're gonna use that. That's not nothing to do with that. Okay, we're gonna use UML. We're gonna use Java. We're gonna use C. That's again, sorry. Actually, that's all right. That's could be a requirement. But for example, design information. We can use for example, 3 subsystems versus 2 subsystems. Okay, or 5 subsystems, or which subsystems supposed to be talking to each other.
User interface.
All right. User interface could be involved a little bit in the requirements.
Because between design and
It is between. I'm gonna get to that. You're a bit ahead of him, but I'm gonna get to that in the next slide, actually. Right? But nonetheless, a very, very specific design information. For example, a certain variable need to be a double versus a long or an integer. That's really specific design information. That's got no place in our requirements document. All right. Now, what's your name, Fed?
method.
Method. Okay. Method just actually alluded to something that is very, very clever. Okay. We like to think that we can draw a line with a sword between requirements and design and say, well, that's it. Okay. We are not going to be looking into the design aspect at all. We're just going to be doing our things in the requirements phase. We're requirements engineers, and so we're much bigger than this. We're better than that. In reality is, as you get towards the design and you're completing your requirements, you have to kind of overlook a little bit into the design, because some constraints, obviously, that we have in requirements will affect our design, but some constraints at the design phase influences our requirements. Okay. For example, going to be using something that is geographically distributed. So a client server architecture is going to happen. Okay. You're going to use a particular protocol to talk to. There's only a certain amount of protocols that exists. Okay. You might have heard the term TCP, UDP, all right, MIME. All right. We can't create our own protocol. Okay. We're not going to change the world of networking just for our software. Okay. So we have to use one of those. Okay. Now, if my requirements is in contradiction with how these protocols work, well, then I can't just be hard-headed and say, oh, I'm just going to keep steady with my requirements. No, I have to actually end up massaging my requirements, changing them a little bit because of what I saw over at the design. Okay. Maybe the way I written on my requirements, had I created a particular design for it, maybe the performance would have been so slow, which is also a contradiction of one of my performance requirements. So I end up saying, okay, well, fine. You don't have to do this way. You can maybe do it in a slightly different way. I'm going to change what I want from you so that you can actually create a design that overall adheres to my set of requirements. So they're a little bit interleaved to some extent. All right. And we're going to talk about this more, obviously, when you guys get to SE 310 next semester, inshallah. All right. Now, to the types of requirements. We have 2 different types of requirements, the first of which is called functional requirements and non-functional requirements. You can kind of split everything into those 2. And the functional requirements are the things that we ask the system to do in general. Okay. The non-functional requirements are the things or the attributes or the characteristics that when the system is doing it, certain attributes or certain constraints needs to be taken into account. It's still confusing. I know. I know it's still confusing, but it's going to get a lot clearer as we get towards the end of this chapter. Okay. A third type of requirement, I know I said 2, but a third different flavor is the design constraint. Okay. So you can think of it this way. If you flip back to the last lecture where a source of my requirements was actually coming in from the design team telling me, well, this is what our systems can do. This is what our design capabilities can do. We can't do much more than that. Okay. You guys are using Java. Java doesn't have that. Okay, you guys are using C sharp. C sharp, for example, doesn't have that library. We can't do it. All right, so then I go back and change my requirement. All right, but we're gonna focus mostly on the two more important ones, the functional and the non-functional requirements. All right, so here it is. The main difference between, pay attention to this, because I'm gonna be asking you a whole bunch of questions right now. I'm gonna see if you're paying attention to this, all right? The main difference between functional and non-functional requirements is that functional, in red, are those requirements where we can write code where the semantic meaning of the code is satisfying the requirement. Whereas the non-functional requirements are those who get satisfied by creating code by which the semantic meaning of the code is not explicitly realizing the requirement, okay? As though the non-functional requirement was actually satisfied as a byproduct of that code being there. And I know, as I'm saying this is flying right over your head, okay? It makes it absolutely no sense. But nonetheless, I'm gonna ask you some questions on it anyway, all right? So here it is. I have a requirement for you. I want a system that adds two numbers together. Functional, all right? Write this down. I want you to write down these questions, okay? Because whatever you, and in the future, please bring something that you can write. You're gonna be using that quite a bit. The first couple of lectures are, yes, me talking and you listening, but as we get more into the course, you're gonna be dealing with hands-on stuff. So one question, if you don't have it, or you can just write it down, yeah, on your phone, that's fine. Just pull out a note. Guys at home, I want you to do the same thing. Now I'm gonna be open up the chat to see what you're answering, okay? So I got the chat here is open. All right. So the first requirement, I said, adding two numbers together. Which type, functional or non-functional? All right, you write down your answer, okay? Well, I'm just soliciting, right? The next question. I want a system. It takes two numbers, adds them together, and then after it shows the output, it shows a little smiley face next to an emoji, and smiley face emoji after that output, okay? Obviously, the smiley face has got nothing to do with the computation of the two numbers. Is the smiley face requirement functional or non-functional? All right, well, write it down, okay? I'm gonna come back and hasib whatever you're saying right now. Yeah? Can I slow down a little? Yeah, yeah. Oh, yes, yes. So, did you get the question, or do you want me to repeat it again? Oh, the second. So the second question was saying, I have the system. It's going to take two numbers in, and I wanted to produce the output. But next to the output, I wanted to show a cute little emoji face. Okay, so the emoji requirement, is that functional, non-functional? Non-functional. Is that what you're writing? Well, like I said, I'm gonna حاسبكم بعد كده what you're saying, okay? We say in Egypt, الإنسان ما فيهوش إلا لسان. So whatever you say, right? Next requirement. Okay, the system takes two inputs, does the addition for it, shows a smiley face. But the smiley face, I want it to be blinking. 1 second on, 1 second off, 1 second on, 1 second off, 1 second off. So that blinking requirement, is it functional or non-functional?
Function.
Write it down.
قال لك لا تقول.
Exactly. Yeah. And after the third one, Girls upstairs? Doing good? Okay, next requirement. Takes the two inputs, gives me the output of the addition, shows a little smiley face, does the blinking thing, but I wanted to do the whole thing before it begins blinking in less than 0.5 seconds, less than half a second. That less than half a second to complete the process, is it a functional requirement or a non-functional requirement? So I wanted to do the whole process that I just said in the last requirement, but I wanted to do the whole thing in less than half a second. That's obviously before it keeps blinking again. All right. So that requirement to be done under half a second Is it functional or non-functional? It's not getting more interesting now, huh? Good. Everybody, next one. Next one, ready? Okay. ما نخبط أي حاجة دلوقتي بس we'll see in a moment. Okay. All right. I want this that interface that I'm using to give the two inputs, okay, to be user friendly. Full stop. That's my requirement. Want it to be user friendly. The interface that I'm using with that software to give the input and to see the output to be user friendly. In other words, easy to use. User friendly. Is it functional?
I feel like I'm in front of a client.
I'm pretty sure the client is not going to be quizzing you about this. Hester, you have a question? Okay. Oh. All right, Nora, Noha, and oh, I see. Oh, you committed too many answers, but that's fine. That's good. That's good. That's good. Oh, look at that. Oh my God. Oh my God. Oh my God. Yeah. But that's good. That's actually what I'm looking for. Wow. No. Okay, that's good. That's good. That's good. That's good. That's what I want. I want this interaction. I want this involvement. All right, one more. Actually, no, let's make it two more. Two more. One more requirement. Like, how many do I give you so far? Five?
Yeah.
Okay, yalla, number 6. وضع عندك, yalla. I want the buttons in the interface to be big, with the numbers big, a certain size. Listen, 1 inch with 1 inch is a really big buttons, with the numbers being in bold and fat, so that they're easier to read. All right, that's my requirement. Okay, and it's a way of making the interface easier to use and more friendly.
Yeah, it's all on the same interface, right? All of this.
Yeah. I mean, the previous requirement is just saying I want it to be user friendly. The second one is saying I want the big buttons with the fat font, bold, big, so they're easier to read. Especially by people and senior people, older people, yeah, all right, or even kids. Okay, that requirement of big buttons, fat font. Okay, fat font specifically mustn't be in size 32, and the size of the button 1 inch by 1 inch, big fat buttons. Okay, is that a functional requirement or a non-functional requirement? Okay, ready? One last one. I want this thing to be done in actually, I'll give you 2 more. Okay. This is how many? This is
7.
I'm giving you number 7, huh?
Yeah.
Okay, so number 7 is that I want it to be done in Java. Let me just sit down here for a second. See what? What? Oh, we're gonna get to that in a moment. Right now, I'm just خليك عمال تضلو, and we'll get back. So the whole point of this is that after we explain the differences, then you look back at your answer and you say, this should have supposed to have been this and this is supposed to have been that. All right. But so it's okay to make mistakes. It's fine. You're in a lecture anyways, right? When I said أحاسبكم عليه, I'm not actually gonna, not explicitly, yeah. So what was that? Java, yeah, okay. But last requirement, last one. Okay, I want it to be the system to be in adherence with the government calculation laws, okay, which doesn't exist. I'm just inventing stuff. Okay, so the government has a rule, says if you're gonna produce anything that calculates, these are certain standards that it's supposed to adhere to. Okay, is that requirement to adhere to government laws that, or in general, that you're not doing something illegal? All right, is it functional or non-functional? And this actually, the last one is probably the trickiest one. Okay,
So the
Depends.
others aren't checking.
You don't want to mess with the government, that's for sure.
Depends on the perspective.
Depending on the government. So doctor, I have to leave now, okay? This is getting too uncomfortable for me. Yes, Nahar.
What do you mean by semantic meaning? يعني اللي فهمت kind of in مثلا we want a program that calculates the square of even numbers.
Mhm.
And the non-functional would be that the result will always be even.
No, that's not what I was saying, no, no.
Okay.
But you're close, okay? And actually, I like that you asked that question because that takes me to the next slide over here. To the next slide over here. All right. So now you can put down your pen and now this is what I was trying to say in the previous slide, which made no sense, is that if I have a requirement, say RQ1, requirement 1, and it says add 1 to the value of X. Okay, and we do that, we use X equals X plus 1. Very simple. Another requirement says the addition of 1 to the value of X needs to be done in less than 0.05 milliseconds. All right. Why? All right. Now, when I see something like requirement 1, I can write code for that. This is the rule of thumb. This is how you differentiate. I can write code for that. Okay. And the code that I'm going to writing is X equals X plus 1. The semantic meaning of the code. What is the semantic meaning? Means what is it that I'm actually instructing the computer to do? Is to go get the value of X, add 1 to it, and make sure this is the new value of X. This is what the word semantic is meaning. The actual explicit meaning of the code. Now, when I'm actually doing this, it finished this in مثلا 0.045 milliseconds, which is okay with my second requirement. But the statement saying X equals X plus 1, which computed in 0.05 millisecond, its meaning wasn't, Mr. Computer, please do this in exactly 0.05 millisecond. It was just a byproduct. All right. All right. Now, if the byproduct itself is not good enough, then maybe I have to see a different way of doing things. Okay. All right. Yes.
That's the thing. And if, let's say, instead of it's just add 1 to the value, what if it's asking us to solve something? And it asks us to do it in less than a certain amount of time. So then
So the sorting thing, which I think you've already finished with SE204, I'm going to write code for that. And I hope that you actually did write code to do the sorting, right? You written statements, the meaning of those statements to the computer is to flip numbers around. Now, when you actually finish and happen to be in good time, there isn't a single line in their code that says system dot finish in less than half a second, 2 brackets, semicolon. That doesn't exist. All right. That depends on the system itself. All right. Now, I'm not saying that if it was more than the time that I wanted, then khalas, and I mean, we're just gonna go like this and say, we gotta find out a way. Okay. So I'm gonna give you like a little example of how to affect your code a little bit to be a little bit quicker. Okay. All right. Yes.
Always be non-functional.
So the what?
Requirement number 2.
Requirement number 2, yes, because I'm not actually writing code for that specifically. There isn't a single line that I could write saying system dot please finish in less than half a second, brackets, semicolon. If I can write that, then it becomes a function requirement, but I can't, and it doesn't exist. Okay, now, let me just move out of here for a second. Okay, let me open the whiteboard, and it's probably got it for things from last semester. That's the first time I opened the whiteboard this. I used the whiteboard quite extensively. Okay, so I cleaned it. All right, so imagine you have this situation over here. You're getting input. Okay, it's an array of student marks. Okay, and you have a loop, for loop, while loop, whatever it is that you want to do, okay? And it takes in that input, the for loop, okay? And then in that for loop, first it checks for the value that you're getting, whether it's a particular range, you know, 50 or less, okay? Then you get, or it's actually 59, then you get an F. I can't really remember, right? And if it was second check, you have if, oh yeah, so I know what the thing is about. Yeah. I always make that mistake. So it's probably about that we can't see the screen. Yeah, there you go. Okay, sorry, Dalal. Okay, it's just a new semester, so I just gotta get used to it. Okay, so Dalal, I'm gonna repeat this thing again. And sorry, guys, I just have to repeat it so you guys know. So I have a an input array like this one. It just got student marks. Okay, I got a for loop over there, and I keep feeding one mark after the other into the for loop, and then the for loop's got a whole bunch of if statements. It's gonna have a whole bunch of if statement. The first one checks if it's the F range. The other one checks if it's the D range, and the second one, and then the D plus, right, and so on, so forth, until the very last one, which is the A range. All right. Now, assuming that I get a mark that is 98. Okay, what's actually going to happen with that? It's going to come in, right? And we do a first check over here, fails, do a second check over here, fails, and do another check, and then another check, and then another check, until all the way where we get to the A range. Okay, now we've done maybe 12 checks before we get to the A range. Fine, I mean, that's just the way it is. Okay, fine. What if I knew ahead of time that, mashallah, the students that I'm dealing with, and hopefully it's not for the case of the example, but it's actually the reality as well, that mashallah, most of you, if not all of you, are A students, if not A minus. Okay. What if I, instead of doing this, I flipped the order and I made it do a check for the A mark first, and then A minus, and then B plus, and so on. All right. And I have 50 students. Okay. Normally, I would have, in the previous design, as 50 multiplied by 12 if checks before I've gone to the last one. Now it's 50 multiplied by 1, maybe 2. Let's call it 1.5. That gives maybe 75. Okay. And the first one gives me a very, very large number. Okay. I can tell you for a fact that this is going to compute in a lot less time than this one would have computed. Okay. So sometimes just a little, right? Now, in all of this, and even when I flipped the if statements, not at a single point of time did I write down system dot please dot finish, right? It doesn't happen. Okay. Within such and such time, it doesn't happen. All right. But let's go back again now to the slides. Yes.
For example, you're creating a program for university,
Okay.
Make your system more efficient.
Yeah.
Quicker. How would you assume today? Because like as you just said, chicken 12 then takes over time for the system to succeed.
Yeah.
So how would you assume for university program?
Well, it's hard to assume for an entire university, but nonetheless, if I have statistical data about how the students are performing over the last 10 years, because been in operation now, it'll face about 13, 14 years now. And I look at it and say, well, how many students over the history of this received an actual A? And I realize maybe it's 50%. Okay. And then maybe less than 2% of the students actually receive Fs, which is actually really the case. Then it doesn't make sense that I actually start off with the F. Okay. Now, if you do it the bell curve, you realize that most of the students maybe in the B plus range, okay, might actually begin with that range first. Okay, it just statistically makes sense this way, that I actually start with B plus, and then the second most likely, maybe A minus, and the third most likely, which is a B, and then the third most likely, which is an A, or and so on and so forth. This is what I would do. All right. When I was explaining this example, I was explaining from the perspective of like a particular class, and I'm gonna write a little formula in my Excel sheet. This is what I was saying, or to read information from an Excel sheet, right? But nonetheless, it's the same concept applies. All right. So the semantic meaning of that code is to actually add 1 to X. The fact that it has happened in less than 0.045 millisecond doesn't affect whether it happened under or before. It doesn't affect that the fact that it's still non-functional requirement, because not at any point did I actually write down, Mr. Software, please do it in less than 0.5 milliseconds. Yes, question at the top. No worries. These are actually, I'm getting good questions. Yes.
But last semester when we took Java X, there was this, like some specification to show an image every like seconds.
Okay. Yeah. Put up an image in a button, for example.
Yeah, like for example, or it's gonna be every 0.5 seconds. So this would be considered a function or non-functional?
You answer me that question. Did you write code for that? Right? Then it's functional, right? If it just happened from the code that you've actually written, and you say, subhanAllah, I was saying something and it did this, then you satisfied a non-functional requirement. But that wasn't the case, all right? I'm sure you've written code to set, well, then the code, the fact that you've written the code and the code, the meaning, the semantic meaning of this is the most important thing, okay? You're actually instructing the computer to do this as the meaning of that code, then that requirement is a functional requirement.
It's the blinky smile face.
All right, we're getting to that. We're getting to that. Okay. Now, this is not to say that anything that deals with timing is non-functional automatic. Okay. Yani, the blinking smiley face, and I want it to blink every half a second on, half a second off, half a second on. I know I said 1 second, but it's the same thing. All right. Now, I can actually write code for that. All right. I have a system.wait function, and it pauses the functionality of something, of a thread in my computation, and it does something for half a second, and then it stops for another half a second, and then it does something for half a second, and so on. So I can actually write code for that. So the blinking, that's a functional requirement. Okay, although it deals with time, but it's something that I'm writing code for, and the explicit semantic meaning of the code that I'm writing is I'm instructing the computer to do something related to half a second, half a second, half a second, half a second, as I've done right here. Okay. Now, is another thing. Okay, it sometimes is the case that the level of which I state a requirement leaves it at the level of being non-functional requirement. For example, and I have a requirement one that says the system needs to be user-friendly. All right. It's not possible to write. Oh, I should. Wow, that's probably a mistake. I should have. I had 2 trains of thought here. I want to fix this in a moment. Where is my? Yeah, here we go. That's the same idea. I was thinking secure, then I flipped it. I gotta repost that slide up to make sure. Okay, so my requirement said, please be user-friendly. I can't actually write a line of code that says system.be.user-friendly. Okay, same thing with security. I can't write a system, something saying system.pleasebe.secure. All right. So at this level, it stays as a non-functional requirement. Now, what are we going to do about it? We want it to be user-friendly. We just like put our hands up and say, "Khalas, there's nothing I can do about it because it's given to me as a non-functional requirement." No, we don't stop there. We look at it and say, "Okay, I got to do something about it." Okay, so one thing I can do, all right, is I create another requirement that is functional to do something else. So again, talking about security, okay, I can have a requirement to have username and password authentication. Username and password authentication, I can write code for. All right. Now I've written code for it to make the system secure. So I've created an RQ2. And I'm gonna write code for the RQ2. I can't write code for RQ1, but with me satisfying RQ2, I in turn have satisfied, at least to some extent, RQ1. All right. All right, so here is a implement password authentication. All right, so RQ2 would be a function requirement, which when I satisfy, it's not a replacement of RQ1. I'm not going to erase RQ1. Okay, RQ1 is still going to stay there, but I'm going to link it with RQ2. Okay, and this linking thing is very, very important when it comes to requirements management. Okay, because I got to know where I'm putting my efforts. Okay, all right, so I've done something, I've hit two birds with one stone. I got to be aware of this so I don't keep wasting my time later on. All right. Not all non-functional requirements, however, can be turned into functional. Okay, so this solution, this elegant solution that I just had, I can apply it everywhere. For example, one of my requirements, which actually happened in the real world, is that the system needs to be written in Java, not C++. Why? Why that requirement actually exists is that that company had all of its systems created in Java. So that new subsystem that was going to be created to be integrated with it, I'm not going to come now and do it in C++ or C# or anything like that. You know, it better be in Java so that it's still in line and the interoperability issues are taken care of. Everything is written in Java. Okay. Now, it is a non-functional requirement because I know I can't just write a line of code saying system.b.develop.in.java. Doesn't exist, right? But at the same time, I can't really actually create a function requirement for it. What I gotta do for this particular non-functional requirement is just make sure that first day on work, I just write in Java, right? Just make sure I watch out for that. All right, let's take some exercises here. Now, I hope you actually getting those answers correct. Right. And then we'll get back to the smiley face and all that stuff in a moment, okay? All right, let me actually see the guys at home. What are you guys doing? All right, there we go. Can I actually clear the chat? You know? No, I can't just clear it. I want to say, okay, type follow. Let me just do this. So I know if you're messing up or not. Type. So this system was about the Dubai metro system, and it's an old example. It was a midterm question at some point, but it's no longer. I retired it. All right, but you're gonna get a question exactly like it. When I say exact, it's not the same exact question. It's similar to it. Okay. But one of my requirements that the system needs to be available 24/7. Guys at home. Faisal said non-functional. Who else? Guys at home. None. Okay. All right. Why is it non-functional?
Talks about the availability.
Yeah, I know, but give me more specific. I know it's better. I can read
You don't
that.
have to code that it should be available.
It's not I don't have to. I can't. I can't. Always think about system.beavailable.20. It doesn't exist. Okay. So first one is non-functional. Good. I want system to monitor the current position of the train. Functional. Okay. Produce. That's good. Produce daily reports. Okay, guys at home. Functional. Good. All right, functional. Okay, it's fine. Operator authenticates user using username and password.
What do you mean by operator?
Operator is the human being is actually dealing with the software. Functional. Okay, I write code for usernames and passwords. Okay.
You have to have the text box.
You have to have the text box. Then you check with the password that's in this files and make sure, right? You're doing all of this, all right? So functional, interoperable with the current system.
You can.
It depends on
Kind of like a Java question.
yeah, depends on
Non-functional. Okay. Again, no such thing as system dot please be operable with the, just making sure that it's kind of like the Java question. Just make sure that when I'm writing it, that I'm writing it so that it is operable with the current existing system. A user-friendly interface. Why?
You won't type in that needs to
Got to be friendly.
Okay. Non-functional. More questions. Store train details in a database. Are you sure?
Yeah, function.
Okay, functional, good. All right, don't let me trip you there, okay? Let me just move this out of the way. The database containing the train details must be from Oracle.
It's like a limited.
It's a brand, right?
Yeah.
Is what?
It's also similar to the Java.
I saw it. Has just one more, sorry. It's just like the Java question, okay? Actually, it's even more if you think about it, because the previous line, I actually write lines of code to hit the database and store information, retrieve information. But there's nothing in my Java code that I would write down and say Java dot make the database dot Oracle, right? So the last one would be non-functional. I have to press on the screen first. Okay, flip up the questions that we had before. Okay, so what was RQ1? Add two numbers together. Functional. Second one was what? Display a smiley face, huh? Functional, yes, because I can display. You've done your Java effect stuff, okay? Display a smiley face, and third one was blinking, half a second on, huh? Functional, okay, because I can control that, okay? The whole thing has to be done in less than half a second. Non-functional. Next one was what? User-friendly. Khas, we dealt with that. And the big buttons, functionals. Okay, I can handle that. And then what was the Java? Khas, we dealt with that. And the last one, adhere to government. Now, here's the thing about the government thing. Well, that's why I was tricky. Okay, unless the government actually said something specific, all right, about certain computations that needs to be done, then I have to implement those in my code. Okay. Yeah, and مثلا 5 plus 5. For some reason, the government says you can't just add the second 5 حتة واحدة. You have to go like 5 plus 1 plus 1 plus 1 plus 1. خلاص, if this is the case, if this is the requirement that I'm getting from the government, I can actually write code for that. Okay. But مثلا, a government requirement could be something like that this code that you're creating is not a threat to national security. Alhamdulillah, we're not a threat to national security. Like that, right? But nonetheless, I'm not actually writing any code specific to say, please don't be a threat to national security. Okay?
So it's functional or non-functional?
So what do you think? The last one about the threat to national security.
You didn't specify what their low is.
No, we're adding two numbers together.
Yeah.
All right. And at the same time, when you tell me that it's not a threat to national security, I'm thinking in my mind, I can't really write a single line of code saying system don't be a threat to. So then it becomes, all right. Now, when we talked about the addition and we said the second 5 has to be split into ones, yeah, I can actually write code for that. I'll split it into 5 plus 1, then plus 1, then plus 1. I can do something about it. So it depends on what is it that I'm getting from the government, so to speak. Yeah. Yes. The what, huh? The button question, yeah.
It must be non-functional, it's related to design.
No. It's I didn't tell you how to make the button in that particular. I just want the button to be big. And I've given you like say a specific requirement for it, okay? Because I'm dealing with the elderly community or dealing with kids, and I'm not gonna have this scientific calculator with the small buttons, and it's very hard to use. You see what I mean? Now, I understand what you're trying to say. You're saying that in requirements in general, we don't actually write, but then we always leave a little open-ended clause at the end saying sometimes my design affects my requirements and my requirements affect my design. So you can think of it this way as well. Although the source of that requirement wasn't actually a design limitation, but rather I know my audience. And for example, there's people, senior people, they like the big buttons. This is why we see our elderly relatives with the older phones, because they like the fact that it's a touch, not touch screen, but an actual physical touch, and the buttons are big, and they like that, right? All right, but yeah, in general, it's not something that I should be specifying exactly. I shouldn't actually be going to that much detail, unless for some reason I have to. Okay.
So very details, it's a function required.
No. You're thinking about you're missing the. If I can write code for it, and the meaning of the code, yeah, the size of the button I can control. I know in JavaFX you can do that. You can put the big numbers with the big font. I can do that. I can write code for that. Okay, and gives it the constructor allows me these options. Okay, so that's the whole point. If I can write code for it, where the meaning of the code itself is instructing the computer to do that, then that requirement is a function requirement. Okay. Yes.
About the database question.
About the database question, yes.
Yeah. Can't you write code for it?
Of course. Not the last one. Okay. So the last one, the one before it is, I can do reads and writes from a database.
Talking about the last one.
I'm gonna get to that. I know, I understand. Okay. I'm trying to relate to the first one before I get to the, because I can do the reads and the writes. That's easy. Okay. Now, picking the brand itself, which is Oracle. Okay. I can't write code that picks the brand for me. All right.
Can't you write code that if the source, for example, is the Oracle takes the database? It's not.
See what?
Can't you write code
Yeah.
that checks if the source is from Oracle?
No, I'm not gonna write to code to check. Okay. All I'm doing is that I'm asking the company who's gonna create that system for me. When you buy a database to be used with that system, like in our university, we have a database. All I'm saying is that make sure that database you buy it from Oracle. We have a deal, Mahom, we get a good discount for some reason, okay? For some financial reason, we're asking for that. It's not about that I'm making sure that, this system that I'm dealing with is Oracle, okay? They're not the enemy. It's something that I control, but I'll adhere to this functionality, to this function requirement by buying an Oracle database, okay? I'm not gonna write code for it. Now, the most critical thing about all of this exercise, okay, is to make sure that our work is focused. I need to know before I begin working and before I begin designing for my work, what is it that I will be designing for? What is it that I'm going to be writing code for? I don't want to end up chasing rabbit holes, chasing sarab, okay? Things that will never be code in itself, all right? And also at the same time, the fact that I am aware that it's a non-functional requirement, I keep an eye on it. I don't just forget about it, okay? In some cases, the non-functional requirements are even more important, okay? Are even more important. For example, all right? I'm gonna give you two examples about this, where the non-functional requirement is actually more important than the functional requirement. Like, we have two protocols for streaming or networking. Okay, we have something called TCP and something called UDP. Okay, UDP cares more about timing than the quality or the correctness of the picture that you're getting, and TCP cares more about the quality, okay, than it is about time. Okay, so if I'm actually sending, if you're watching a football match, all right, it's supposed to give you a nice resolution of a certain quality, okay? But at some point, the network is not as strong, okay? There's a bit of high traffic, all right? Now, you would rather have a slightly less perfect picture and to get to see when the player is actually shooting the ball and when it's actually, if it's gonna go into the, I mean, if it was, imagine it was a penalty, all right? All right, even with a slightly lesser resolution, i.e. not so perfect of an answer, okay, that would actually be better, and I adhere to the performance, versus of buffering, freezing the thing for 3 seconds to make sure that the picture is going to be good, but then the shot is already gone, okay? So this is a situation where the non-functional is actually even more important, okay? Another thing, all right, let's take the banking domain. Okay. Yes, it's great that we can move our money around, pay bills and so on and so forth. Okay. But what if this thing is not secure? All right. That's the class, it's out of the window. All right. it is out of the window. So there's certain situations where the non-functional could be even more important than, okay, even not even as extreme. Let's just take a look at this Java and C++. I mean, imagine the new company came in, right, and they build that software with C++, and now we have the Java mega system that already existed. And now for the next 10 years, we're facing all of these interoperability nightmares because the company that came in and created the system created it with C++ instead of creating it with Java. Okay. Now, to me, I'd rather the system be functionally not so perfect, but please, please, please just have it done in Java to begin with. All right. So I'm not saying this is more important than this or that, and what's more important than that. Okay. When you sit down with the customer, yes, when you sit down with the customer, what you listen to a lot of the time is the functional requirements. It's very rare that a customer would actually be explicitly aware of non-functional need. You have to bring that up. And this is where our job comes in as a requirements engineers. Okay. Our job comes in as requirements engineers when we understand, because we're coming in as from a software engineering background, and this is an advantage we have over the business people, is that we know software. We've created software before. And we can sort of like see down the line, when we create software for this, given this particular set of requirements, am I going to face trouble downstream or not? So I can say now, uh-oh, this is not going to be able to happen. You can't do this and that at the same time. All right. A classical example for this is, you know, if you have like an entertainment system in your car or a GPS. Okay. Back in the day, you could either have this or that. Now you can actually have both. The same system does both. But because it used to be the same compartment. So you can't just go in on the website with building your own car thing and say, I want this and that at the same time. Or in other words, I want to have 17-inch wheels and 21-inch wheels at the same time. All right. This is where the website says, okay, you think you've done something stupid here. All right. You can't have two size wheels at the same time. It will actually say that too. Well, none of the word stupid, but it will actually say you can't actually have that. The other thing too, is where we come in as software engineers, is that stakeholders or customers tend to tell us what they want rather than what they need. Okay, I know this example is a bit outdated, but you know, your customers say, what car do you want? And the customer say, I want a Ferrari. It's exciting, it's a sports car and so on. And then you say, okay, Mr. Customer, you actually have a family, you have 6 kids. There's no way you're gonna fit them all in this Ferrari, okay? But now there is an SUV Ferrari that exists, and now this example is a bit out of date, but you get the gist of what I'm trying to say, okay? But we're not, the point that I'm trying to say is, it's not like in a restaurant where you just say something to the server and the server just writes it down and they're just relaying your request. Even with no disrespect to servers, even at restaurants, sometimes the server tells you, you can't do this and this at the same time, or this is, for example, out of stock, we don't have that, and so on. All right, so a little bit of a roadmap. Within the requirements phase, we can actually split that into 2 different phases, a problem domain and a feature domain, a solution domain. And the problem domain, the 2 domains, they form something like a pyramid. I'm going to slip here a few slides here until I get to this one. Okay, you got the text later on, you can look at it, but I'm just going to explain what was actually in there. Okay, so all of this, let me just make sure I do have the pen. All of this, we're still in the requirements phase. Okay, now at the bottom here, I'm going to draw a line, and here at the bottom, this is where you have your design. Okay, you haven't reached the design yet. Still, okay, and this you're gonna like this. You're at the top. What's your name? Okay, this actually touches upon the point you were just trying to say in the moment ago. Okay, at this stage, okay, so this is the day 0 of the project. Really, we have no intuition about the solution that's ever gonna be. We have a fresh, clean slate of, tell me what's your problem. Okay, and when the customer is saying, hopefully they're actually saying the needs. Okay, I need this, I need that, the students are suffering with the registration, that this is slow, we have a lot of conflict in the schedule, and right? They're telling us the needs. They've given us, from these statements, 100% a problem, 0% a solution, okay? Now, those needs, any need that I get, I end up creating a number of features for it. Let's just say F1, F2. These scammers. F1, F2, and F3. Okay? Features, okay? So the system shall do this, and the system shall do that, and the system shall do that. Together, when it does F1 plus F2 plus F3, it solves the need. And this is one way to solve the need. Okay? So here's two things. F1 plus F2 plus F3 is a way to solve the need. So I'm actually writing down what is it that I want the system to do. But also at the same time, I've chosen a particular way. So there is a little bit, I'm leaking in a little bit of the solution as well, because I could have chosen F4 plus F5 plus F6 to do that need. All right. So in the first top of that pyramid, the possibilities were infinite. The moment I go to the gray middle area, I have closed down the solution space even for the designers later on, because I'm asking them to do F1, F2, F3. All right. But still, I'm writing it in the way that, this is what I wanted the system to do. All right. I haven't yet explicitly said how. Now, little later on, even this F1 gets transformed into something called software requirements. Okay. And the software requirements tend to be rather detailed. Okay. Talking about certain protocols, certain this and that, tends to be details where the customer probably doesn't know about it and probably doesn't care either. Okay. They'll probably be involved with you and they'll follow you first, the first two phases. Beyond that, it's up to you. You deal with it. Okay. This is where the designers here at the bottom are interested, because this is what they're going to get, the specific software requirements. Please be as specific as possible. Okay. So you're giving the designer, right? I want a bridge. This is the point A, point B. There is, a distance of 525 kilometers. They want that. Okay. Customer, from their point of view, I just want to bridge from here to there because we have a network traffic here and I have a network traffic over there. All right. But then as you get to S1, S2, and S3, you're committing, you're doubling down. You're committing more that design space, you're shrinking it down, and then you're given that shrunk down space to the designer and say, yalla, within this space, yalla. Right? This is kind of like, my version of democracy. I tell you what I want, and then you're free to do which way you want, right? But that's after I have sort of like limited to you, right? So this button example, again, we get to that, right? I've sat down with my customer. The customer is not going to tell me 1 inch by 1 inch and a font 32. But I, as a requirements engineer, and I looked at the senior, I realized this is probably a good thing to do. Now, how to do it specifically, obviously, there's not that many options. You're going to be using the JavaFX. I mean, this is really the one line of code. But nonetheless, it could have been a particular room. Okay. All right. Telecommunications is a very good example of this. You get, customer, I need to communicate with others, not using phones because it's, it could be listened into, eavesdropping, and it's expensive and all that stuff. So I say VoIP, okay, voice over internet, IP, okay? But within VoIP, there's many solutions, okay? Now, I said VoIP. I didn't leave the whole world of communication open to the designer. I shrunk it down a little bit, but still within that VoIP world, I left it up to the designer to decide the specific solution. But what I'm trying to say here is that, so as you're going down this line, okay, here really it's about 0% solution. All problems, okay? Over here, right, a little bit of solution starts to leak in, okay? And maybe 90% problem. And then over here, even more of the solution starts to leak in and 70% of the problem. And then this is where it feeds into the requirements team, and then the requirements team start to work with it, okay? So like I said, the needs, just you're sitting down in a restaurant, this is where you have your fancy restaurant, you're sitting down with the customer, they tell you, you know, this is my problem, blah, 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 right? And then maybe at the end, you start to talk about some features, and, you know, we can have the system check for this, we can have the system check for that. This is the level of features, okay? And then as the requirements engineer is sitting down with the designer and say, all right, for that particular feature, you know, we want to do work with this protocol, with this technology, with this, and this, that, right? Without actually being too explicit about the design. Okay, they're giving them the specific requirements. All right. Just one last thing just to nail the point through. Okay. I'm going to use that next year as well. Okay. When you walk into, say, Best Buy or Jarir or something, and you want to buy an iPhone. Okay. What do you say? I want to buy. That's it.
No,
Say the model you want.
Okay. Like what? Yeah.
And how many gigas?
Okay. Good. And like, give me an. Yeah.
The design in general.
It's the whole design? No, not the whole design. Okay, so you're saying I want iPhone, was it now X what? Well, is it 13? 12, huh? Type with a few Pro, few مش عارف
Yeah.
All right. Size of the memory is such and such, and the color. Usually very, very, very important. Okay. Now, do you think this is all the specifications of an iPhone? No. If you actually look at the technical details, there's hundreds of specifications. Okay. And when you flip the phone, it says designed in California, built in China. Okay. Now, the people in California better give the people in China very specific details. Okay. And they're giving them the requirement. Actually, they're giving them design, but the same thing deals with the requirements. Okay. Is that you have to give certain very specific requirements to the designers, and the same thing follows, right? Right. So this is what I'm trying to say. As with the customer, the level of detail stops. Okay. You know, for example, the refresh rate of the camera. If I tell you what that is, and you're standing in the store, you're like, oh, all right, whatever. Okay. So it's a good camera, right? I can take a good picture with it. And you probably, that's it. Yeah. All right. Okay. So that's it for today. Any questions about today's lecture? Okay. So the flip back and forth over here, this one over here. Okay, this question, you're gonna get something like this in the exam. Okay, quiz one. Yeah, but so I haven't said the data, but it's gonna be quiz one. All right. Okay, guys. Yalla, I'll see you on Wednesday, inshallah. Take care.
Thank you.
Yes.
Taking notes.
Yes.
I'm almost closing the I can't take notes.
You don't have to anymore. Let me just stop the recording.